We're going to be continuing our investigation into resiliency with Michael Dunaway from the Information Research Institute, the University of Louisiana at Lafayette. So.
Thank you. Well, good afternoon, everyone. I'm Michael Dunaway. So Roger's presentation and mine are effectively the voices of the canaries singing in your subway system. Because what we're experiencing in Louisiana and what Roger has been modeling is potentially the future. So that's what this is really focused on. Most of you are probably familiar with the Rising Tide, John Barry's extended study on what happened in the Mississippi River in the 1927 flood, and the outcome of that, which was the Mississippi River we currently have, which has a built infrastructure along the entire length of it, pretty much. And there are a lot of unintended consequences like that with that, and we're living with them right now down in Louisiana. By the way, I pulled this off this was off the New York Times yesterday, as a matter of fact, and we're headed in that direction in some way or another, some sense or another, with more storms and rising seas. Which cities should be saved first? And it'll come down to questions and balances between who can afford to be saved and who cannot be. Do we give them up? Do we move the populations? And I'll touch on some of those factors that we're dealing with right now. I want to point out that the reason I wanted to highlight John Barry's book is actually the subtitle, The Great Mississippi Flood of 1927 and How It Changed America. Based on what we're seeing right now, we're at a point of inflection right now at exactly that. So the question we want to ask is 100 years from now, what are the decisions we're making today that are going to affect us in ways that we predicted and wanted, or ways that we did not predict and did not want? And that's where we are right now, because we're living with the effects of engineering design done in 1927. So here's Louisiana. There's Mississippi River. I pulled this off the website just a little while ago. The Morganza Spillway is right here at a point where the Mississippi River bends. Baton Rouge is down around here, and New Orleans is down around here. The Morganza Spillway holds this leadoff water from the Mississippi River, which is opened at occasions when you want to relieve pressure upstream so as to protect Baton Rouge, the state capital, and also New Orleans. So this spillway was predicted to be opened about 3 weeks ago, and fortunately the Mississippi River floods have stopped right now, and they're beginning to recede very slowly. I was just checking the weather on this morning. The Bonnet Carré spillway between the Mississippi River and Lake Pontchartrain has been open since May the 1st, which is the longest period of time it's been opened since its construction. And that water has been bleeding into Lake Pontchartrain and then going from there, Lake Pontchartrain, out into the Atlantic Ocean, or into the Gulf, rather. And you can see that the Mississippi goes all the way down here with this point of land. Well, as we build more infrastructure on the Mississippi River, what that does is it narrows the channel, increases the velocity of flow, and carries the sediment from the upper part of the United States, not to the plains of, of Arkansas and Louisiana and other areas, carries it all the way out to sea. That's why the river entrance keeps growing, because the sediment stops in the Gulf of Mexico, and we're having to continually dredge. So we're basically shifting land from the upper part of the United States down into the Gulf of Mexico. And that's essentially the unintended consequence of the efforts that were started in 1927 to rechannel the Mississippi and control it. So we're controlling it all right, and we're seeing some consequences. That I should point out, by the way, that photograph over there is Westville, New Jersey, last week. So that's a June 20th photograph of a place about 70 miles from there, or 80 miles from there, I guess. So we're seeing these consequences all over the United States right now in terms of weather pattern changes. This is a New York Times from 2016. This is the first resettlement of a U.S. population as a result of climate change, if you don't mind using that term. This is the Ile de Jean Charles, southern Louisiana, way down here. This is a Native American community. Real irony in the fact that a Native American community had to be the first evacuated as a result of sea level rise along the coastal region of the United States. This article was published it was a very long article in the New York Times Magazine about 3 years ago. In 2016, we have had really significant flooding in in Louisiana. In fact, more extensive than Hurricane Katrina. And it was not caused by a hurricane. It was actually caused by a storm center that stopped over Acadiana and Baton Rouge region and sat there for 4 solid days. I've never seen rain. I was in the Navy for 27 years, been through a couple of hurricanes at sea. Never seen rain like that. Old-timers who lived in the region had never seen rain like that. They reported that their grandparents had never seen rain like that, and flooding. And this was the outcome of it. So as a consequence of that, we chartered, whoops, sorry, wrong direction. We chartered a whole series of studies of the region to try to determine on a broad scale what should we do regionally to solve this kind of flooding problem. One of which was this. A friend of mine at the, one of my colleagues at the University of Louisiana in Lafayette, I was a hydrologist, Imad Habib. So I was in the Emergency Operations Center. I run the Business Emergency Operations Center for the state of Louisiana. And during that flooding series, I got this call from the local energy provider, one of our 2 major companies. Where do we put the sandbags? Rather odd question coming from an energy provider. Well, the reason was that, so this is the Amit River that is to the east of Baton Rouge. The flooding was so severe it had exceeded the floodplains that had been mapped and that were provided for even in a 500-year floodplain mapping problem. In fact, the floods in August of that year were a 1,000-year flood. And the energy departments were calling up because their substations for the electrical power distribution system had been built inside those 1,000 floodplain regions because, frankly, we didn't know what that 1,000-year flood looked like. So what they wanted to know was which substations are most in danger and where do we ship the sandbags to first, because they were sandbagging substations. So there's a solution to a real problem. So what Imad did is he did a 3-dimensional flooding mapping that was more detailed than any flood maps that the energy providers had or that FEMA had provided for Louisiana at the time, and it included a time component. So when will the water get X high on what day? And that was what he was looking at. So here just a little bit more of the detail on that. This is the floodplain and along the main channel of the Amit River and some of the modeling that was done there to solve that problem. So we basically told the electrical power company, start here, go here, go here, go here, and sandbag those first. And fortunately, we were able to preserve the electrical power grid for the most part. I belong to the Regional Smart Transportation Council, or the Louisiana Supply Chain and Transportation Council in Louisiana. And as a result of flooding, we have done what is a statewide transportation network design. And we got some preliminary work that we're doing in this, and it's basically to pull together an entire cultural, economic, engineering, ecological, environmental study group to look across the entire state and do collaborative planning at the state level to try to determine how to make the multimodal transportation system in Louisiana more resilient. And one of the things that we're doing, this is a very preliminary design. I know this is a little hard to understand. That's a 40-foot shipping container inside a high-speed vehicle. It's moving about 350 miles an hour. It's inside a vacuum hyperloop tube that we are looking at as a design from New Orleans over to the Lake Charles region. And we're looking at an initial preliminary stage, about 70-mile test platform. This is out into the future. This is basically the Elon Musk hyperloop for freight. And that's what we're looking at. And the reason we're looking at it, so this is magnetic levitation system, high-speed printed hyperloop thing. We don't bury tubes in Louisiana. We put them on stilts, and the stilts are floating on they're not floating in the surface. Obviously, they're floating in the soil bed itself. And the tubes themselves are 3D print welded. The design is that they're 3D printed, they're flexible enough to be able to absorb that. And that's kind of the preliminary design work. It's just begun. This is a long way into the future. Here's why we're doing this. So here's Lake Charles, New Orleans, Lafayette. The 70-mile segment is the initial part that we're looking at right now. The reason we're doing this is because we want to be able to resupply the Lake Charles liquefied natural gas terminals that are coming online. We've got about $120 billion over the next 10 to 15 years of investment in that region. This is the largest LNG terminal in the United States. Right now, we're doing a lot of shipping to China out of this region. You probably read this. Here's the problem. The piping system, I didn't have a map. I couldn't see a map for you. So the piping system from here to New York City, Boston, Philadelphia region has about 6 days of petroleum in it. That means if we suffer a casualty down here in the winter, it's going to get mighty cold in New York City about 6 days later. Been a lot of design studies on that in terms of the impact at a strategic level of this region of Louisiana relative to the electrical power system and also the petroleum system for the United States, and what that means up in the upper end of the country. So anyhow, that's that project right now. I wanted to point this out, and I'll quit here. So we have a mountain in Louisiana. Most people don't know this. It's Mount Driscoll. And it's at 535 feet elevation. If you have the moxie to be able to hike this thing, you can sign a little sign here at the top. There's a little box. There's a little register. You put your name in there. There's a club of people that go around the country and they go to the highest peaks in states and whatnot. Okay, here's Manhattan, by the way, 265 feet of elevation. And we're at 500 and some odd feet. Now, it's going to take a long time for the water to lap up here in Bristol Mountain, but it will already be lapping over Manhattan well before it ever bothers up us in northern Louisiana. So when you're thinking about, I was very interested in Drew Markowitz's presentation about the I-35 corridor project, which is built, of course, on the barrier islands. They don't call them that for nothing. So the thing you want to be thinking about out into the future is, will that really exotic and very impressive engineering project to redesign the infrastructure system along the barrier islands of New York, is that going to be there in 100 years, or is it going to be an archaeological dig 100 years hence? So we need to be thinking long term about what we're doing right now, because the engineering design work that was done in 1927, we're living with the unintended consequences in Louisiana of that right now. So the question for all of us, I think, is not simply to solve today's problems, it's to actually think about the problems in the very long term, because that's the infrastructure we're building for the nation. So that's essentially my presentation. Thank you. By the way, for New Yorkers, I use this slide all the time because this is a slide of optimism. And I use that a lot.
Any questions for Michael?
Yes, sir.
Okay, like the hyperloop kind of
Can
transportation.
you maybe stand up?
Yeah, just like wondering why these are like the hyperloop style transportation.
Yeah, because it's, well, for one thing, it's a very high-tech application of a problem we already know we have. But the problem is, and this happened in the flooding in 2016, when the floods get really deep along the rail system, what happens is not that the trains can't flow, which, I mean, the trains stop, of course, but the problem is the railroad ties scour as a result of flowing water. So you have to go back and re-inspect the entire rail line and do a lot of engineering inspection work, but also you have to rebuild a lot of that. We see this in our bridges, obviously, and the abutments and the bases of the bridges, but it happens along the entire line of the entire length of the rail line. It all has to be re-inspected. So the receding of the water is not what delays the resumption of freight travel on the rail systems. It's the inspection process which you have to go through and the repair processes, which can be significant. So we're looking at that as a rapid method of being able to improve the resilience of the rail system.
All right, thank you very much.